So today we are going to start with quantification of elements and compounds. This is the chapter 7 coming under chemistry, right? Quantification, qualification, quantification. What do you understand by these two words, children? Qualification and quantification. What do you understand? Quantification. Qualification means telling some features, no, features of something, qualities. You mention the qualities of something, right? So quantification means writing in numerals. Okay, numerally representing something. Okay, you're going to represent something in numeral forms. So we are going to deal with numbers here. Okay, in chemistry, here we are going to deal with numbers. Only few notes you will be writing here. Okay, most of the time we will be doing calculations. Especially, you need to use your log tables, not to use calculators, right? Since you are doing online sessions, you might use your phone calculators or other calculators because I don't know, right? I'm not seeing your faces or something like that. So you're not starting your video during the sessions. So I can't see your faces. So don't go for the calculators because calculators are not allowed during the final exams, right? You must use your log tables. You should know how to use your log tables. Right. So you must use your log tables to find the values, to find the final answer, right? Okay. Here, quantification of elements and compounds. First one, relative atomic mass. Here, first of all, we are going to learn about relative atomic mass. Atomic mass means what? Mass of an atom. You know what is an atom, okay? Atom is the simplest unit of a matter, no? The basic or the simplest unit of matter is the atom, right? So we are going to measure the mass of it, mass of the atom. You all know matter is a tiny particle, no? Tiny, very simplest unit. So for that simplest unit, we are going to measure the mass, right? Okay. So you all know when we measure the mass of other substances, like big substances, big objects or big substances, we use uh, kilograms, grams, and if it is small, we'll be using milligrams, not tablets and all, we use milligrams, okay? So grams, kilograms for sugar, when you buy sugar from the shop, when you buy rice from the shop, okay, you measure using the units kilogram, gram, and milligrams, right? So these are the commonly used units to measure mass. You all know about this, right? Kilograms, grams, and milligrams, you all know, right? If you don't know, you have to revise your grade 2, 3 books. Okay. So here, um, right, discuss with the teacher and the students in your class about the units suitable to measure the mass of the following. Right. What is the unit used to measure the mass of a car? Car, you might have learned in mathematics. First of all, I'll tell you what are the units of mass. We have used up to now milligram, gram, kilograms, tons. Have you heard about tons, children? Ton.
Yes, miss.
Okay, good. So how many kilograms is 1 ton? How many kilograms is 1 ton, dear?
1,000 kilogram equal to 1 ton.
Yes, very good. Okay, 1,000 kilograms is equal to 1 ton. Okay, right. So tell me the units to measure the mass of the car, motor car. Hmm? What is the unit used to measure the mass of? Can you use milligrams, grams, or kilograms, or ton? So, please answer me. What is the unit used to measure the mass of a motor car, children? Quick, don't waste time. Milligrams, grams, kilograms, or ton? Tell me. Soon.
Ton, miss.
Ton. Okay, so taking a lot of time to answer, right? Next one. A brick. A brick. Soon, children, answer me quickly. Kilograms. Okay. A loaf of bread.
Gram.
Grams or kilograms. Okay. A tablet of medicine.
Milligram.
Tablet of medicine. Oh, okay. Milligram. Right. So we all know up to this, right? So here in this chapter, we are going to measure the mass of atoms and molecules. Those things you all don't know. Up to now, you all don't know, right? A molecule of carbon dioxide, a helium atom, how to measure, right? What are the units used to measure, right? So you all don't know about that. So we are going to study about that. No? To measure the mass of items like a motor car, a brick, a loaf of bread, a tea, a teaspoonful of sugar, and a tablet of medicines, units like kilogram, gram, and milligram can be used. Yes, so these units can be used to measure these kinds of mass, like big items, right? Okay, kind of big items. Kilograms. How do you mention kilograms, children? How do you write kilograms? Capital G, capital K, capital G. No, right? Simple K, simple G.
Simple G.
Kilograms. Yeah, always you have to use simple K and simple G. Grams, it should be simple G. Milligrams, it should be simple M and simple G. Okay, right. Okay, but if the mass of very small particles such as carbon dioxide molecule or a helium atom is given in units like kilogram or gram, the value obtained is extremely small. So when you measure the mass of carbon dioxide molecule or when you measure the mass of helium atom, okay, those are so tiny, very small particles. So when you measure them using grams or kilograms, it will be like a very small value, extremely small value you will be getting in like 10 to the power minus forms, right? 10 to the power minus forms you will get, like 0.00000 something like that you will get when you measure it in grams or kilograms. Okay, so that will be very difficult for us to do calculations, right? If you have 0.0000 something like that, it will be very difficult for our calculations, and we can consider, like commonly we can consider it as a negligible mass. No? Negligible mass, have you heard of the word negligible? We don't consider that it is 0.000 something. No? So it is negligible mass, right? Okay, so even the attogram, the smallest units of mass, is too large to indicate the mass of atoms or ions. Yes, there is a unit called attogram, children. Simple A, simple G. Okay, there is a unit called attogram. Okay, attogram also, like attogram is smaller than milligram. Attogram is smaller than milligram, right? So even that we can't use to measure the mass of atoms or ions. One attogram, they are saying it is equal to 10 to the power minus 18 grams. One attogram is equal to 10 to the, no need to memorize this one, children, no need, right? One attogram is just, know this one, 10 to the power minus 18 grams. Okay. Right. For example, mass of an atom of the lightest element. So what is the lightest element in the periodic table? You all know all the elements of periodic table first of all 20 elements, children. Who didn't memorize all 20 elements yet? Hmm? You all
I know,
know?
miss.
Very good. Can I please hear that? Dilrukshan, say all 20 elements, please.
What, miss?
Say all 20 elements from the beginning. Hydrogen. You have memorized. Did you memorize all 20 elements, children?
Yes, miss.
Then tell me, Dilrukshan.
Yeah, miss. H for
Okay.
hydrogen.
Hmm. No need. I just need the order. No need the symbols, right? Just tell me. Hydrogen, helium, like that. Just tell me the order.
Sodium. Sodium.
Order. Hydrogen, helium, lithium. Order. You don't you know the order, dear Dilrukshan?
No, miss. Not order. Only the name is 20.
Anyway, you have to learn in order, right? Okay. Definitely, you must memorize in order. Others, Priyavardhana, Padma Priya.
Okay, miss.
No,
So,
miss.
didn't you learn the elements? I think it's chapter 3, right? 20 elements.
பொய்க்கு ஒன்றும் தெரியாது எனக்கு மட்டும்.
Dilrukshan, mute your mic. Okay. So nobody knows the order, right? Hydrogen, helium, lithium, beryllium, all 20 elements in order. You have to memorize, children. So how did you study chapter 3? I think it's chapter 3, right?
Yes,
At
miss.
least, yeah. Do you all know the symbol? At least the chemical symbol. If I say sulfur, it's capital S. If I say potassium, capital K. Do you all know that at least?
Miss,
Answer
Yes,
me.
miss.
Okay. If you right, if you don't know, please ask. Please tell me. Okay. If you say only, I can realize what you know and what you don't know. Right. So now only I came to know that you all don't know the order. Definitely you must know the order because you need the atomic number, right? Okay, if you know the order only, you can write the elements atomic number. Okay, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. These are the 20 elements. You must memorize this, children. Okay. Luckily, I asked you all. So, shall I fix a date to tell? Okay, by next Monday, can you all memorize all 20 elements, children? By next
Yes,
Monday.
miss.
Okay. So, I'll be asking.
Okay,
Can somebody,
miss.
yeah, somebody has to remind me to ask next Monday. I'll be asking all 20 elements, right? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Like this, you have to tell, right? And I don't know, some people have memorized some songs or something like that, putting the first letter. I don't know. So some people memorize a song for this to learn the elements of periodic table or something. But I don't prefer that because I don't know that song and I don't prefer that. Instead of memorizing that song, you can memorize all the elements. I think. Okay, some cinema song or something like that is there. Right. Okay. So here, children, among the elements, the lightest element is hydrogen, the first element. Okay, the first element, number 1. is hydrogen, right? So that is the lightest element in the periodic table. So that is having the lightest element means it is yeah, we consider it as a unit mass, lightest one. We consider it as a unit mass. Okay, so the mass of hydrogen is 1.674 into 10 to the power minus 24 grams. 1.674 into 10 to the power minus 24 grams. No need to memorize. Okay, no need to memorize. Right. Okay, that is when you write it 10 to the power minus 24. See, so there will be 23 zeros, no? 23 zeros in front of 1. Am I correct? Count it and see. 23. There should be 23 zeros. Am I correct?
Yes, miss.
Yeah. Okay.
Yes, miss,
So you
23.
have 23 zeros, right? So see the value 0.0000 like that, it's going on, right? So we consider this as a negligible mass, so smallest mass, right? Smallest mass is possessed by hydrogen. Masses of some other atoms are given below. So carbon atom, they have given 1.993 into 10 to the power minus 23. So we'll be using this mass. We'll be using carbon mass of carbon atom in our calculations. Okay, 1.99 into 10 to the power minus 23. Better to know this value, right? Carbon atom, you can just put a star mark there. Better to know this value, 1.99 into 10 to the power minus 23 grams. Actually, I didn't memorize this mass of carbon. By doing calculations, you will be doing several calculations, like, right, like more than 10 to 20 calculations you will be doing. So when you do calculations, automatically this mass of carbon atom, you will know it. Okay, you will memorize it, no problem, right? You will be writing it several times. 1.99 into 10 to the power minus 23, you will be writing it several times, so automatically you will know that, no problem. Mass of sodium atom, no need, 3.819 into 10 to the power minus 23. So see, minus 23 means you will be getting 22 zeros in front of 3. Okay, so mass of chlorine atom, so that much small is an atom. Okay, atom is the smallest unit, right? So if you look at the values, children, the values are very small, right? Extremely small. Atom, the mass of an atom is extremely small, right? It is cumbersome to use this type of small figures in calculations, right? It is uneasy, no? It is uneasy to use these small figures in calculation. So for this reason, the mass of a selected atom was taken as a unit, and the masses of the other atoms were given relative to it. The mass so expressed is known as a relative atomic mass. So among these masses, children, among these masses of atoms, we are just going to select one particular atom. Okay, just going to select one particular atom, and we are going to relate the mass of other atoms with this. Okay, among these, get focus on the lesson carefully, right? So among the masses of these atoms, children, so here they have given carbon, sodium, chlorine, and potassium, right? Masses of these elements they have given, right? So among these atoms, we are just going to select one atom, okay, one atom, and we are going to represent the masses of other atoms. We are going to represent the masses of other atoms relative to it, relative to this particular atom. We are going to relate the other masses of atoms with this selected atom. Understood? That is called relative atomic mass. Atomic mass means mass of an atom. Relative atomic mass means relating to the mass is related to the selected atom. Understood? Here, this one. Children?
Yes, miss.
Yeah. So, okay, for in further explanation, you will understand this more clearly, right? The relative atomic mass is not the true mass of an atom of an element. So, we are like relating and saying the mass, right? We are going to represent the mass of other atoms by relating to this. So, it's not the actual value. It's not going to be the actual value. Can you all understand? Okay, I'm going to just compare and write the mass of this particular atom. So that's not going to be the exact mass. That's not going to be the exact mass. Okay. Padma Priya, you sent me a photo. What is that? How is she? Padma Priya, I think she has joined an incorrect link.
Okay, miss.
Just send her the link. Okay. Right. So it's not the true mass of an atom, but the mass we are going to obtain for that atom is more or less equal, right? More like approximate value. It's going to be an approximate value, not the exact value, but approximate value. Right. So in the past, the mass of an atom of hydrogen, the lightest element, was used as a atomic mass. So early days for the calculations, people used mass of the atom. People selected, I said now we are going to select one particular atom, right? Mass of one particular atom and going to relate with the other masses, right? So early days, people used hydrogen, 1.674 into 10 to the power minus 24 grams as the selected atom. Early days, it is the lightest element, so they use that one. But later on, okay, they face some problem with the hydrogen atom. Okay, they face some problems with the hydrogen atoms and they avoided using hydrogen atom. Nowadays we are using mass of a carbon atom. See, mass of a carbon atom is 1.993 into 10 to the power minus 23 grams. Nowadays, we are using mass of a carbon atom to represent the relative atomic mass. Okay. So, atomic mass unit means just the mass of an atom. Just think, okay, atomic mass unit means mass of an atom, right? So the mass of the unit relative to which the masses of other atoms are expressed is called the atomic mass unit. Okay, so whatever the mass of unit mass means one, no? Unit means one, right? So mass of the unit relative to which the masses of other atoms are expressed. Okay, so we have selected one mass. Okay, we have selected the mass of an atom and we are going to relate that mass with the other masses of the atoms. Okay, so that is called atomic mass unit. Understood? So here in this class, I have selected Padma Priya here. Okay, Padma Priya is the mass of the unit. Mass of the unit. Okay, Padma Priya is the mass of the unit. So I'm going to compare, I'm going to relate Priyavardhana, Steve Rogger and Dilrukshan with Padma Priya. Okay, I'm going to relate, right? So if I relate like that, that is called here atomic mass unit. So the mass of the unit is relative to which the masses of other atoms are expressed as the atomic mass unit. Okay. Right. So nowadays, atomic mass unit is, yes, see. If the meeting ends, please rejoin, children. Okay. Now look at this whiteboard carefully. Very, very important, children. Okay. If you once understand this one, it will be very easy for you to continue, right? Okay. But it's not difficult. It's simple mathematic formula, right? Okay. So one atomic mass unit. So atomic mass unit, I told you that we have selected carbon atom. Nowadays we are using carbon atom. Okay. So atomic mass unit is equal to just 1/12 of carbon carbon 612 isotope. I can write like this: mass of carbon 612 atom or isotope, right? So you all know carbon has isotopes. Do you know that? Do you know that, children? Carbon has isotopes. First of all, you all know what is. Do you all know what is isotope? What is
What means
isotope? Yeah?
ice?
Isotope. You're hearing the word for the first time.
Ice mean ice
Isotope.
cubes, miss.
Aye, Tilrukshan.
No, miss, I can
Isotope.
hear properly.
Isotope. It's isotope with Tilrukshan.
Don't know, miss, I didn't hear.
Isotope. You all don't know about isotope. That's unit 3, children. So how did you study unit 3? Huh? Without studying unit 3, jump to unit 7. I want to know what happened before this sessions. What happened, children? Are you clear with 1 to 5 units? No doubts? What about friction?
Yes, miss.
How did you study 1 to 5 chapters? Are you clear with the chapters? I don't think you all are clear with the chapters. If you have any doubt, please ask me, okay? If you are not clear with the chapters, ask me what are the chapters. Wait, I'll ask one by one. What is the first one? First chapter is about the biomolecules. What about that? Was it clear for you all? Is it clear?
Yes,
Any
miss.
doubts in biomolecules? Hello. Biomolecules, you all got, yeah, highest was 70 odd, no? So that is, only 2 of you all did the exam. And the highest was 70 odd. That means you all didn't understand it fully. The first chapter even. What happened to the second chapter? What about second chapter? Distance, displacement, motion in a straight line. What about that? Open your mouth and talk, then only I can do something for you all. I can help you. Be friendly with me, children. Just talk with me. I want to know whether you know. If you know, just tell me. Yes, I know. If you don't know, tell me. Padma Priya don't
Don't know,
know
miss.
gravitational force. Okay, Padma Priya in okay. Right. Chapter 2 is in doubt.